So on to the fourth part of this chapter, we're going to learn about logarithms. Well, logarithms are simply the inverse function to an exponential functions. So if exponentials are a superhero, logarithms are a supervillain. So if we start off with, say, y equals a to the x, an exponential function, then if we were to take a to the other side, the function to the other side, on the other side it becomes a logarithm, and it's called log to the base a. And the x just drops down to fill in the gap. So example 6 asks us to write as a logarithm 3 squared, which is equal to 9. So the base 3 moves to the side to become log to the base 3. 2 drops down, you get 2 equals log to the base 9. B, 2 to the 7 equals 1 to 8. Again, the base moves over to the side to become log to the base. 7 drops down to fill in the gap. So 7 equals log to the base 2, 1 to 8. And C, 64 to the half. Remember, half means square root, so positive square root of 64 is 8. So writing that as logarithm, the base moves to the side, half drops down, half equals log to the base 64 of 8. I mean, one common error I say here is when the base moves to the side, it's to write 9 to the power of 3. And just remember it stays as a base. So the base here will stay as a base on the other side. On the calculator, just so you know where the button is, so say for example log to the 3, 9 here. So log to the base 3, 9 equals 2. Because that's how you put it into a calculator. Okay, example 7. This says to rewrite log to the base 3, 81 equals 4. So we're just doing the same as before. So we're taking log to the base 3 to the other side, and it becomes 3 to the power of. So it'll become a base on this side. So 81 equals 3 to the power of 4. And again, the common error here is to bring log to 3 over and put 4 to the power of 3, which is wrong. Remember, the base stays as a base. So log to the base 3 becomes 3 to the power of. Same way here, 3 to the power of becomes log to the base 3, the opposite side. B, log to the base 2 of an 8th equals minus 3. So log to the base 2 becomes 2 to the power of. So an 8th equals 2 to the power of minus 3. Example 8. Work out without using a calculator log to the base 3, 81. And if I say that equals x, and then move that to the other side, it becomes 3 to the power of. 81 equals 3 to the power of x, so therefore x would have to be 3, 9, 27, 81. X would have to be 4. B, log to the base 4, 0.25 or a quarter. I'm going to call that x. So log to the base 4 moves over, its inverse operation is 4 to the power of. A quarter is 4 to the power of x. What does x have to be? Well, you should know x has to be minus 1. 4 to the minus 1 is a quarter. C, log to the base half 4. So that's going to become half to the power of. So half to the power of what is 4? Well, we know a half squared is a quarter. So to make it 4, we just make the power negative. So x equals minus 2. Half to the power of minus 2 is 4. And finally d, log to the base a to the 5. I'll call that x. So log to the base a becomes a to the power of. So a to the power of 5 equals a to the power of x. Well, then clearly x has to be 5. Okay, example 9. Use your calculator to find the following logarithms to 3 decimal places. A, log to the base 3 of 40. I'm just going to whack it in the calc. We wanted it to 3 decimal places, so that's 3.358. B, log B 8. Now, if you remember from previous work on this chapter, E is simply 2.718, etc. Now, on a calculator, I mean, you can type it in like that. I'm sure you can actually. Oh, maybe you can. But on the calculator, log to the base e has its own special button, ln, for the natural logarithm, which is here. So if you want to do log to the base e8, you simply press ln 8. 2.079. And c, log to the base 1075. Now, in older calculators, log to the base 10 also had its special button, which was just log, but it's not on these newer calculators anymore. You have to type in log to the base 10 now. 1.875. And that is all the examples on this part of the chapter. So if you now have a go exercise 14D.